Hey, this is Micah Morris, and this is my MAOL 630 lesson. This is a seventh grade lesson over statistics and probability, and this lesson is called probability with cards. I'd probably start this lesson by playing a trailer for the movie 21, which is a movie about a college professor at MIT who takes some students out to Vegas on how to count cards, and then they end up winning, millions and millions of dollars. I'd probably check your school principal on showing that trailer in school, especially to seventh graders, because the movie is about gambling and counting cards. But I would open up and share. I'd open up the class and start with that trailer, and then afterwards pull out a deck of cards and then ask the class, this is a deck of cards here. We got 52 cards. Well, what are some of the characteristics that we know is in a deck of cards right here? I'd field questions and say, yeah, we got four different types of cards that are in here. We got hearts and diamonds. People pretty much remember those. The other two suits are called spades and they're called clubs. A lot of people think they look like clovers, but they're called clubs. And those four things, those are called suits. You got the suit of hearts, diamonds, clubs, and spades. And each suit has 13 cards. And I'd ask students, if they can remember what the 13 cards are. And we go, yeah, ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2 at the very bottom. So then I would pull out a deck of cards and say, okay, I got a deck of cards right here. Which do you think is more likely? If I held out a deck of cards, do you think it's more likely just to draw the one singular 5 of clubs, or more likely to draw any red card from the deck? And if I took all these and put them back in the deck, which is more likely, drawing one or any of these red cards? And students would hopefully answer, the red cards. And then I would follow up with, well, how do we know that? How do we know that this is more likely than just this? And so we would do the math. Remember, there's 52 total cards in a singular deck here. And if reds make up half of the deck, that's 26 red cards versus just one of these. So the probability of drawing a red is 26 out of 52, whereas this is just 1 out of 52. So there we've got our probability, we've got our fraction, and we know that this is more likely. The likelihood of this, the value of that fraction, 26 out of 52 reduces to 1/2, which is a greater value than just the 1 out of 52. And we can keep on and doing more examples with the cards, but I would also have like a presentation to go along with it. And let me share my screen to just kind of go through what some of those questions would look like. We'd be discussing with students the whole time over these. Here we go. So my next question would be this: which is more likely to happen, drawing any diamond or drawing any black card? Okay, well, to draw a diamond, it is one of the suits out of a deck of 52. So there are 13 cards in that one suit. So we'd say, okay, that's 13 cards out of the 52. And that would reduce to, oh, look at that, 1/4. So that's the probability, the likelihood of drawing a diamond. Drawing any black card, well, black cards make up half of the deck here. So that would be 26 out of the 52 cards, which becomes the fraction of 1/2. So which one is more likely to happen? The drawing of the black card, because it is a higher probability. That fraction is higher than the probability of drawing a diamond. All right, the next question: which is more likely to happen? Let's do one more here. Drawing any ace or drawing any king? This is a really good question here. So I'd ask, all right, how many aces do we have in the total deck of 52 cards? Well, we've got 4 aces, one of each suit, 4 out of 52. And I'm going to put that as aces, 4 out of 52, which will reduce to 1 out of 13. Now, for doing kings, well, there's also 4 kings: a heart, a diamond, a club, and a spade. 4 kings out of the 52 cards, and that also reduces to 1/13. So actually, that's a draw here, pun intended, with drawing cards. Neither of these are more likely to happen because they have the same probability of 1/13 and 1/13 right here. Now we could do the next few examples here, but for the sake of time, I want to skip down to this this last one right here. Which is more likely to happen? Drawing any heart, diamond, or club, or drawing a spade? All right, so we're combining suits here. Any heart, that's 13 cards. Any diamond, that's 13 cards. Or any club, that's another 13 cards. So drawing together that, what I'm going to call a combo, drawing those 13 types of cards is a 39 out of 52 probability, which reduces to 3 over 4, 75% chance. Whereas just drawing a spade, that's another suit of cards, which is 13 out of 52, which will reduce to 1 over 4. And this brings us to a good point here. Obviously, we can see that this fraction of 3 over 4 is the bigger one. It's more likely to happen. But this is something also key that we haven't seen. This is the first fraction we've seen that's bigger than 1/2. And in probability, if you see a fraction that's bigger than 1/2 and close to 1, it means it's more likely to happen. Whereas any fraction, like this 1/4 over here, that's less than 1/2 or closer to 0, is least likely to happen. So if you're ever presented with a scenario where you're doing the odds or probability of something, and your odds are greater than 1/2, it's likely to happen. Whereas if your odds are less than 1/2, it's not as likely to happen. So then after working with the deck of cards, maybe students have their own decks, I'd put away those supplies for right now, and we'd pull out some paper examples so we can do just a couple right here. So we've done enough card examples. Let's go ahead and skip this first one here just for the sake of time. Let's jump to number 2 here. Susan has a bag of 12 marbles. 4 are green, 2 are red, 2 are blue, and 4 are pink. Which is more likely to happen? Drawing a red marble or drawing a blue marble, and what are their probabilities? All right, so we had 12 total, and we're looking at red and we're looking at blue. So for the red, we had 2 out of 12, which will reduce to 1/6 right here. I'm going to highlight that in red just to keep my line straight here. Highlighting that in red. All right, for the blue, turn off the highlight just for a second. For the blue, we said that there are 2 marbles out of the 12 as well. Oh, we're going to see something similar here. That'll reduce to 1/6. That is my blue probability. I'm going to put that in blue. And so we see that these actually have the exact same fraction here, the exact same chance of happening. So we would say that neither are more likely to happen because they both have the same probability. You could draw red, you could draw blue, but neither has an advantage over another. All right, last question. Steve is playing Monopoly, and he needs to pass a go to collect $200, that wonderful game of Monopoly. He needs to move at least 4 spots on the board game. If Steve rolls 2 dice, is it likely that he will pass go? Now, this is interesting here. He needs to go 4 spots, and we're rolling 2 dice here. Now, each dice has 6 sides, and if you're rolling 2 of those dice, 2 times 6 will give us 12. So we could move up to a total of 12 spots, but Steve needs to move at least 4, and we can go up to 12. Let's fix that typo right there. Now, a lot of students will make this mistake, and I'll kind of pause right here. They might think the fraction is supposed to be 4 out of 12 because that's all we need to move, and it's less than 1/2, so it's not likely to happen. But we need to look at the flip side of this. He could go past 4. Actually, we can go all the way up to 12. So actually, it could be 8 out of 12 because we can go past 4. So actually, this is our probability right here. And that is going to reduce if we divide top and bottom by 4. There's my equal button. That's going to give us 2. Oh, wait, no, we can divide. Yeah, divide by 4. That'll give us 2 over 3. So that is my probability of passing go. And you know what? That is higher than 1/2. So my question is, if Steve rolls the dice, is it likely that he will pass go? Well, after seeing my fraction of 2 over 3, yes, that is likely. Final answer, yes, typo. Yes, it is likely that Steve will pass go and that he will collect his $200. Students would then get a 5-question exit slip that are very similar to these examples right here. Okay, we'll stop sharing. Stop recording.